Today I'm going to go ahead and go through the notes. A couple of people missed some of the beginning of the class for 1.5 on the first day, so I'm really not going to spend a lot of time working through everything. I trust that you can read, but I am going to go through and fill in the blanks so that you'll have a copy of this and that you can go back and check over it for yourself. A combination of numbers, variables, and operation signs is called a mathematical expression. The reason why I'm going over terminology is because when you do your online homework, they're going to give you instructions and they're going to tell you things that you need to do, and they'll be using some of these terminology, and that will just help you. The next blank, it says this expression usually has sum or difference of terms. A term is a real number, a variable, or a product or quotient of several numbers and variables. Examples of terms are, so each one of these could be classified as a term. The symbol that's in front of the term is always part of the term. So here, this is an understood plus sign in front of this term. This is obviously a -4, so that negative, treat that as a negative. It might look like a minus sign when you see it written out in an expression. Think of it in terms as a negative when you're adding and subtracting though. And here we have a negative, and it's in the fraction form, 3/5. Unfortunately, yes, you're going to have to do things involving fractions, so kind of get used to it. A numerical value in front of a term is called a coefficient. I know that there's a question on the homework that asks you to identify terms, list all the terms on something, and then it also says list the coefficients. If no number value appears before a variable, it is an understood 1. So if you just have an x by itself, so if you just have x, or you have y squared, okay, there's an understood 1 right there in front of those. So it might be helpful to put a 1 right there when you're working, just so that you know that is one of those items. When we string together terms, the resulting expression is what we call a polynomial. That just means it's a group of terms. Later on we'll talk about specific polynomials, if it has 2 terms, if it has 3 terms, depending on how many terms it has. But in general, we just call it a polynomial. It means it's got a group of them. So here's some examples of problems you'll have like on your homework on this section. There's only like 8 or 10 questions on the first section. It says list the terms in this expression, so we would have 7x as one of the terms, and then the next term keeps the negative sign with it, so we would call that -2w cubed. The coefficients are the numbers that are in front, so the coefficient here would be 7 or -2 for the coefficients. Now when you're filling this in on your homework, there's going to be a little template at the bottom of the page, and it allows you to do your exponents. So you'll have to, it's tedious, but you'll just have to get used to it. Okay, so on the next one there would be 1, 2, 3 terms, because there's a plus sign and a minus sign that separates those. So you would have 5y to the 6th, comma, -2z. And I put a line in the middle of my z so it doesn't look like a 2. And then on the last one you would have 3/4 wn to the 4th. Okay, the coefficients are the numbers in the front, so 5, comma, -2, comma, 3/4. Okay, so that should get you through about the first 3 or 4 problems on your homework. We can add and subtract terms if they are like terms. That means they have to have exactly the same variables, and they have to have exactly the same variables and exponents. And we can use the distributive property when we're going to combine terms. So we have to identify the terms by their exponent. So if I have xy squared, that's not the same as x squared y. Because when we write these, this would technically be an x times a y times a y, and this would be an x times a y. So you can see the results are two different quantities. Basically, your exponent expression with the variables is the identifier of what it is. It's kind of like a label if you talk about grocery store things. This might be Heinz ketchup, this might be Del Monte, but that's because they have a different coded thing. So when you add like terms, you have to make sure that they have exactly the same terms that you're going to add. So here we're going to use the distributive property, so we're going to combine the two numbers, but we're going to keep the variable. So if I have 8 of these items, whatever they happen to be, plus 2 more of those items, now I just have 8 plus 2 of those items. I have 10 of those items. It doesn't change the kind of thing, so the variable is not going to change. You're just changing the number of items that you have. So over here I have 3x squared y's, and here I have a negative 12x squared y's. So the kind of thing is an x squared y, and then you just combine. I've got 3 minus 12, or 3 plus a negative 12, you'll have negative 9, and you keep it as x squared y's. So just a note, a variable expression never changes when you add or subtract. Now, here's a couple more examples that just go through. I'm just going to go through and write these out. I have some x squares here and I have x squares there. Sometimes you'll see students draw a line under them and then go ahead, but notice that x squared needs a 1 in front of it. So you can think it or you can write it, but then we're going to go back and combine. So for x squares, I have 7 plus 1 x squared. For x's, I have negative 2, and over here I have a 5. So these two would be combined together. So I have a negative 2 plus 5, and that's going to be for the x's. And then at the end, I have just some whole numbers. I have a negative 8 and a negative 12. So I have, that shouldn't be there, whatever that is. That should be negative 8 and minus 12. And those are called constants. I'll write that in there. So if you have a term that somebody says the constants, that means just the whole numbers that don't have any variables with them. So now just go back and add. So I have 7 plus 1, that's 8x squared. And then plus negative 2 and 5, that would be 3x. And then I have a negative 8 and a negative 12, which would be negative 20. And this would be your final answer. It's just an expression with numbers together. Okay, now on this next one, I've got some things that have like terms because they both have ends, but notice the numbers on them are fractions. So I have to have a common denominator for those fractions. So when I'm going to do this one and this one, I have to go 2/3 plus 5/6. Well, 6 can go into 6 and 3 can go into 6. So what I need to do is make this 2/3 into a 6. So I'm going to multiply by 2 to get it to 6, and whatever you do on the bottom, you do on the top. So now I have 5/6, and this becomes 4/6. So I'm going to add those, and I'll have 9/6. So my ends will be 4/6 plus 5/6. So that'll be 9/6 in. And then for the whole numbers, the constants would be a negative 4 and a minus 7. That'll be minus 11. Now the only thing you have to go back and look at on this one is that 9/6, both have 9 and 6 have a factor in common. So I need to reduce that 9/6 down, and then the final answer would be 3/2 in minus 11. I squeezed in too much space right there. So this would be your final answer. There's no need to change 3/2 to a decimal value. Just 3/2 like it is. There's no more nothing else you can do with it. And in algebra purposes, having it in a fraction form is better than having it in a decimal form. Okay, here at the bottom, we're just doing decimals. That's the only thing. So we look for x cubes and we go look for more. We've got some more right here. So I'm simply going to add 2.3 to 5.8. That comes out to be 8.1 x cubed. You'll use your calculator. negative 5.6 and a negative 7.9. They both have x's with them, so now I can combine those together. They're both negatives, so that means I'm just going to be accumulating negative numbers. So the sign will be negative, and then I add, so that'll be 13.5 with an x. So those are adding and subtracting. Then the next group has multiplying expressions. Now this is where I put 2 stars. Now when you multiply, you're going to have to combine factors that are there. So if I have a 3y and I'm going to multiply it times the y squared, this means I have one factor of y, and when I go to here, I'm going to have 2 more factors of y. So now I have to count the factors. So technically this is 3y, y, y, which would be 3y squared. Now when I multiply the second ones, I'm going to just multiply the numbers, so I have 3 times 5, sorry. So plus 15, but I have a y from each one of them, so I'm just going to write that. Oh, this should be cubed. Cubed. And then I'm going to write the last one as 15, but this time I have y to the second power because I have 2 y's that are in there. So when you multiply the numbers together, you combine the variables by just adding the exponents of the ones that are alike. So here, I'm going to multiply 5, and remember there's a 1 in front of that. Oh, there's going to be a 1 there. So I'm going to multiply 5 times 1 for the first terms, and I'll get 5 here. There's 2 a's, and 2 more a's will be a to the 4th because I'm just going to add their powers. B, there's not any more, so I just drag it along. Then go to the next one. 5 times negative 1, so that'll be a minus 5. And then I'll have a squared. That's 2 factors of a plus 1 more, so that would make a third. And then b, that's 1 plus b again, that'll be b squared. Then go to the next term. So that was that one. Now we're going to go to the 6b squared. 5 times 6, that's plus 30. A squared. And no more a's, so that will stay a squared. 1b, and I got 2 more b's here, so that would be b cubed. Now I go all the way to the end, and I have 5 times constant, so 5 times 2 would be 10. And then I just drag all the variables because they all have to be there. There would be your final answer. Okay, so now we go to number 2 example. Negative 7n has to be distributed to both of the terms. So I'm going to have negative 7 times 2 will be negative 14. I have 1 n on the outside and 3 more inside, so that's going to end up with 4 factors of n. And I don't want to have to write them out like this every time. That's why I'm just going to use the powers. Go here, negative 7 times negative 4. It's going to be positive 28. Negative times negative is positive. N and n makes 2 factors of n. Now, when you have a negative sign and there's no number there, that's an understood 1. So we can think of that as negative 1 being multiplied all the way through. So multiplying by negative 1 isn't going to change the numbers, but it will change the signs. So really all I have to do is go through the parentheses and just change the signs. So this positive 3 turns into negative 3y. The negative 2, negative, negative, becomes positive 2z. And the positive 6, negative times positive would make negative 6k. And then at the bottom one, we're going to multiply, and we got a fraction on the outside. So I'm going to make my 8 and my 12 and my 3 look like fractions. And when you multiply fractions, you multiply straight across. So I'm going to multiply straight across and then come down and reduce. So if I multiply, I get 24 over 4 times 1, so that's over 4x squared. Then you could do this in your head, 3 times 12, so 3 times 12 will be 36, and I'm going to divide that by 4 times 1 would be 4, so that's x's. And then go to the last, I have a minus, 3 times 3 would be 9. 4 times 1 would be 4. Now go back and look. I'm going to put these in little speech bubbles here, little clouds. This is what, you can think this in your head and not have to write this down. So you could go and have already see 24 divided by 4, well, that'll be 6x squared. 36 divided by 4 would be plus 9. And then I have a minus 9/4 out here. Now 9/4 is a reduced fraction. There's nothing else you can put into 9 and divide it into 4. So that one's fine, just like it is. There's no reason to put it in a calculator and come up with a decimal value. That fraction is better to be left like that than it is to do to make it a decimal. So this is all the information that you need to do 1.5. So you should be good with that. So anyway, I think that's all we need, and we will stop right there.